Okay, so in this video we're going to be talking about successors and predecessors and what they mean and how do we find them. Okay, so I'm just going to write down some definitions. Okay, so say we choose a node X, that the successor of X is the smallest node greater than X. Alright, so just a quick example. If X is 13, the smallest node greater than X in this tree is 17. Or sorry, if X is 15, the smallest node greater than 15 is 17. And if we said 13, just for example, the smallest node greater than 13 is 15. Alright, so then what's the predecessor? The predecessor of X is the greatest node smaller than X. Okay, so how do we find these? So first of all, let's just look at a couple of examples for a second. So let's say if X, let's just talk about successors for a second. So X is equal to 15, then the successor of 15 is equal to 17. Okay, and let's look at some others. If X is equal to 13, then S of 13 is equal to 15. And let's see, one more. What's a tough one? This one's not too tough. X is equal to 9. Then the successor of 9 is equal to 13. So if you think about it, let's just draw these paths. So 15, we have to go to 17, right? So that's 15 to 17. 13, we have to go to 15, right? And then 9, we have to go to 13. Okay. So let's try to see if we can notice anything about this. Well, if we look at 15, right? 15 has both a left child and a right child. So we know that the successor is going to be greater than 15, right? So the successor is going to be somewhere. The successor is going to be somewhere in the right subtree, right? Now, where exactly in the right subtree is it going to be? Well, it's going to be at the smallest value in that right subtree, right? So it's going to actually be the leftmost value of the right subtree. So what we would do is we would go into the right subtree, and to find the smallest most value, we would keep going left until we can't go left any further. So a little mini algorithm. So to find successor, if X has right child, then go right, and then as far left as possible. Okay. So now let's see if X does not have a right child, right? So let's look at 13. 13 does not have a right child. So what you have to do for 13 is you have to try to find a parent to the right. So you're going to try to see if there's a parent on the right of 13, but there isn't a parent on the right of 13. So you're just going to have to keep going. You're going to have to keep going left until you can make a right. And then once you make the right, then you're going to be at your successor. So else keep going up left until you can go right, which will be successor. Okay? So just think about it. Let's just see if this works for anything. So let's see, we want to find the successor of 4, right? So does 4 have a right child? No, it does not. So then we're going to keep going up left until you can go right, which would be the successor. So we go left 3, we go left from 4 to 3, and then we can go right, and we get to 6, and that is going to be the successor, right? So I think that pretty much works for anything. So even say we're at 2, and we want to find the successor, we don't have to go left, we can immediately go right, and that brings us to the 3. So that's how you find a successor. Now, this predecessor is pretty much the same thing. So let's try to write the algorithm for the predecessor by just replacing a couple of words. Here, I'm going to zoom out a little bit so we can see a lot of stuff. Okay. So we're going to see. So I'm going to write this in white. To find predecessor, if X has left child, well, let's just think about it, because I'm going to pretty much try to like swap two things and see if it works. So I'm going to rewrite it if I swap left with right and predecessor with successor. So if X has left child, then go left, and then as far right as possible. Alright, so let's just look at this one for a second. So X has a left child, so let's look at 15, right? So we know that the successor of 15, or sorry, the predecessor of 15. The predecessor of 15. We know that that's 13, right? So let's see, does X have a left child? Yeah, 15 has a left child of 6, right? So we're going to go left, so we go to 6, and then we go right as far as possible. So we go 6 and 7, 13, we can't go right anymore, and then 13 is it. Okay, so then that works. So now, let's see if it doesn't have a left. So let's see which one doesn't have a left child. 7 doesn't have a left child. So let's see, the predecessor of 7 is going to be 6, right? Predecessor of 7 is going to be 6. So I'm going to write else keep going up right instead of left until you can go left, which will be predecessor. Okay, so let's look at 7, right? So I'm going to keep going up right until I can go left. So 7, I can go left immediately, right? I don't have to wait till I go right. So I go 7, I go up left, and I get to 6. Now let's look at another one. So let's find the predecessor of 13. Find the predecessor of 13. Well, we know the predecessor of 13 is 9. Does that work? So if x has a left child, then go left as far and then as far right as possible. Well, we go left, right? So 13, we go left to get to 9, and we go far right as possible. We can't go anymore. So that works too. So let's try to find another one that doesn't have a left. Let's see. 6 has a left, 3 has a left, 7. There's too many left. 7. Yeah, so that's pretty much it. Like it will pretty much work for anything. So if you want to test it out for yourself, you could see that this is going to work for anything. And yeah, so that's the general idea of this. And then I'm going to go into something else after this.